Hello everyone, we're JMARK Systems and today we're going to be introducing our MAVS systems. My name is Roy, I'm an electrical engineer specializing in power systems and communications.
I am Jeffrey Barajas, I'm an electrical engineer specializing in power.
My name is Miguel Harman, I'm a computer engineer with a minor in computer science, specializing in computer science.
My name is Armando, I'm a computer engineer as well, specializing in biomedical engineering.
My name is Keith Melville, I'm a computer engineer and I specialize in
My name is Miguel, and I'm going to explain to you a little bit about our project. Our project is called MAVS, which stands for Modular Automated Vehicle Systems. As you know, when we're playing crosses at sea, the way to find it is to look for the beacon. This is a time-consuming task. So our project consists of making vehicles that communicate with each other to make the task of finding the beacon easier and less time-consuming. As you can see, we have a grid, and this is going to be representing the beacon. So the two vehicles will communicate with each other to find the beacon faster.
Hello, I'm Keith, and we're going to be explaining the overall description of our project here. Now, we're going to start over here with the beacon itself. The beacon is going to give out a 400 megahertz signal. That signal is going to be caught by the signal strength meter. Now, the signal strength meter is what we're demonstrating today, and it takes in an analog signal, determines the strength of it, how far away it is, changes it into a digital signal for our microcontroller to understand, and then we work on that data. Also here we can see our GPS module, which is responsible for getting the positioning of our systems in each unit so they can communicate with each other where each other are, and so the users can know where they are. Also, so we can define the search parameters, in other words, the size of the grid and where the bounds are. And then the XV communication module, this is the main method of communication between units and to the user. This is our interface. It takes in signals from a wireless interface, 802.1.15 Zigbee, and it sends it to a microcontroller. We work on that data. We also send signals out because this is our communication. Microcontroller is the main control unit. Now, this block doesn't just represent the microcontroller chip, but it also represents the memory and other onboard things to process. And finally, we have our output signals to our vehicle. With this information gained here, we tell our vehicle which way to move. This represents a logic circuit and various servos and motors, and the propulsion system, essentially telling our system where to go, forward, backward, left, or right, all controlled by the microcontroller. This is the part that can be switched out to be used in different vehicles. Our example is on land, but should it need to be in water, we could change it out for a more submarine approach.
Okay, this is a demonstration for the signal strength meter for the MAVS system from JMARK Systems. As you can see, this is the antenna, and this is the op-amp and an LED driver. The signal is going to come through the antenna, it's going to get amplified on the op-amp, and the LED driver is going to take care of signaling the signal strength. As you can see, when the transmitter comes closer to the antenna, the signal strength meter captures the strength of the signal. As you can see, when it goes away, the signal fades. Therefore, the closer it gets, the more lights you get, green being the maximum signal. Right now it's calibrated for a demonstration. The system is capable of detecting the signal much further away by regulating the potentiometer that controls the gain of the op-amp.
Okay, this is part 2 of our test. Right now we are going to test the range of our receiver. As you can see, Armando will turn on our transmitter and we're going to have a full range in our signal strength meter. Now he's going to start walking away to test the range of our receiver. At about 10 feet we can see that our strength is about almost half the way, and he's going to take it a little bit further now, and now we're talking about a good 20 feet. And as you can see on the LED bar, the range should be very, very small, almost zero. And now we're gonna test it backwards. Now he's gonna start closing in on the antenna, and as you can see, the LED bar, it is showing that it's receiving something, and he's gonna start walking in closer. He's about 10 feet in, and as you can see, is the meter is increasing, which means the signal is very, very strong. Right now he's about 2 feet in, and we got a full bar. This definitely concludes that our design for our receiver is working, and we have a good prototype for our MAVS system.